Formulas, Coordinate Geometry, and Applications by Sapling. By the way, this is the third video of the series and the last one for now, so I would recommend you watch the two videos before it to understand more. Today we will be talking about the standard equation of a circle, the distance formula, the midpoint formula, the arc length, the area of a sector, the population density. So let's start off with the standard equation of a circle. So the standard equation of a circle is right here, but first we're going to make sure you get what these things are. They're not just a bunch of letters, okay? X and Y is any point on the circle, any singular point. As I've previously mentioned on my videos, any point of the circle is equidistant to the center of the circle. So if you take any point on the circle, it will work. HK is the center. It's the coordinates of the center. Okay? So then, when you look at the equation, it makes sense. Okay? X minus h squared plus y minus k squared is equal to r squared. R is the radius. Okay? So now, if you really want to understand the depth behind why is this equation, how do I find out things? Why are they equal to each other? Well, let me show you. Okay? If you know the Pythagorean theorem, which is a squared plus b squared is equal to c squared, this makes sense, okay? X minus h squared, right here, plus y minus k squared, right there, is equal to r squared. So basically, if you take these points, if you take any point in the circle, subtract it to this, what does that give you? It gives you probably something along that line, and then it tells you what this is, and the other one tells you what this is, and then you find out the radius is, and when you square root that, you get what the radius is. And you can do that if you have, like, let's say you have any point on the circle and you have the radius, but you don't have the center, you can plug in values and find out what the center is. You can do that with any of them. So I have an example here. What if your equation shows like this, okay? Sometimes it's not just about the circle, sometimes it's about rearranging the equation so you know how it is, okay? This is called perfecting the square method as well. X squared plus y squared minus 8x plus 4y is equal to 16. So what you would do here is you would put all of the variables together, like x squared minus 8x plus y squared plus 4y, and then equal to 16. Then I would start perfecting the square. X squared minus 8x plus 16, that would perfect the square to x minus 4 squared. And y squared plus 4y, if you add 4, you make it y plus 2 squared. Now remember, the 16 right here, you have to add the things you add on this side, you have to add on this side. 16 plus 16 plus 4, okay? And if you have this, right, x minus 4 squared plus y plus 2 squared is equal to 36. From here, we can figure out the center is 4, negative 2, and the radius is 6 because 36, the square root of 36 is 6. Okay? Now we're going to go on to the distance formula. So the distance formula is this. D is equal to the square root, all over, of x2 minus x1 squared plus y2 minus y1 squared. So we're trying to find the distance. For example, we're trying to find the distance between 2, 3, and 6, 9. Okay? I'll give you a few minutes to do that. Okay, so now let's solve this, okay? I'm going to make my own little thing here. What is x2? So remember, 2, this one is x1, y1, x2, y2. Okay, that's enough from slope, right? So now, what is our x2? It is our 9, no, it is our 6, minus 3 squared plus 9, oh, I accidentally wrote 3. Okay, this is supposed to be a 2. Sorry if I'm messing you up right now. 4 squared is 16 plus I'll let you guys put that in your calculator really quickly. Okay, it is the square root of 52. All right? Square root of 52. Sort of messed up right there in the beginning over the x2 and x1s, but it's all right. Okay? Now we're going to move on to the midpoint formula. Okay? You can start simplifying that to 213 and 7.21 or something like that. Okay, now we're going to move on to the midpoint formula. Okay? So the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. So for an example, we can find the midpoint between 4,2 and 10,8. I'm going to give you a few moments to find out what that is. And now I'm probably going to just solve that like over here or something. Okay, I'll have my work the next time you see me. Okay, so 4 plus 10 over 2, which is 7, so that's our x value. And 2 plus 8 over 2, which is 5. So you got 7, 5 as our midpoints, okay? So the answer to this problem right here is 7, 5, okay? So now let's move on to the next part, arc length, area of a sector, and population density. So for arc length, let's go on to that part. Okay? Okay. So the arc length formula is the arc length of AB over 2 pi r is equal to m AB over 360. Okay? So this might not make sense right now, but that's alright. Okay? So, what you're going to do first is I'm going to give you a practice problem. Well, actually, I'm just going to explain this to you first, okay? So, over 360, this is where the angle goes. This is the angle. Okay, this is where the angle goes because over 360, that's how many angles it is, okay? 2 pi r is the formula for the circumference. And so basically, this is a proportion. This out of this is equal to how much out of this. That is basically what it's saying, because 2 pi r is equal to 360 degrees. That is all this is saying. Okay? For a really simple example, let me give this to you, okay? The arc length, okay, no. So you have to try to find the arc length. The radius is 4 and the angle is 90. Okay, so what's the arc length? We don't know that. We know it's 2 pi r, so 8 pi. You have to pause the video because I'm already solving it. And this is 90 over 360. Okay? So my handwriting sucks here, but if you can make out what it says, you see how this is 1/4, right? So let's just act like, let's like remember that this is 1/4. Let's just act like this is a 1/4 right here. And remember, this is 8, okay? So this is 8. What is this? That is basically what it's asking us, okay? So the answer would be 2 pi. Because as you see, 1/4, what would be the x? The arc length of this is 2 pi. Basically, how you solve arc length is gonna be exactly how you solve area of a sector, except with a different proportion. So I won't be showing an example for that one. Okay? So here's the area of a sector. It's basically the same thing. This one was arc length of AB. This one's area of a sector. APB basically just means the sector. Instead of the circumference, we have the circle area formula because we're trying to find the area, not the circumference. Again, the angle, and again, 360. So it is basically the exact same thing. You're plugging in, basically you just need the exact same numbers, again, except you're getting new stuff. Okay? And using all of this in many word problems in math, there comes population density. And you're like, what? I learned what arc length is, I learned what area of a sector is, but I don't know what the population density formula is. So it's very helpful to know what the population density formula is. It's very easy, it's very logical. Population density, or PD, is equal to the number of people and the area of the land. So if there's 500 people and there's 5 miles, then, which is, yeah. But if it's like that, for example, then this would be the population density. Okay? In many of the area of a sector problems, that's what comes in handy afterwards, like the area of the land. Thanks for watching. Please like and subscribe for more videos like this one, and watch the other videos in the series. Bye, thanks, Sapling.